Okay, hello everybody, and welcome to this webinar on the topic of closed loop urban farming. Thanks everybody for being here. As you will see, this is a Zoom meeting where you can see the other participants, you can write in the chat, but we would ask you to keep your cameras and audio off for the first part while our presenters are speaking. In the second half of the webinar, you're very welcome to turn your cameras on and your audio on if you want to ask questions, because the second part will be an open discussion. So I would just like to welcome our speakers today. We have Ina Zoimel here from the Edible Cities Network project, which is the project which is organizing this series of webinars called Global Lunch Talks on Urban Food Innovation. And we also have two representatives of project partners. That's Erwin Nolde from Nolde and Partner Innovative Water Concepts, who's based in Berlin, and Martin Regelsberger from the Transition Towns Network Oststeiermark, which is in Austria. We're going to start today with a short presentation from Ina Zoimel, who's the principal investigator of the Edible Cities Network project, and then move on to our talk from Martin and Erwin on closed loop urban farming, recycling water and reclaiming nutrients. And then after that, we're going to open the floor for questions from all of you. And that's where you're very free and welcome to ask anything. If you have an urban farming project of your own and you want tips and advice, that's the time to ask for it. You can also throughout ask questions in the chat if you want, and we will also get to those at the end. So now I will hand over to Ina, who's going to talk a little bit about the Edible Cities Network project.
Yes, thank you, Marisa, and hello, everybody. A very warm welcome to this webinar, and thank you to Erwin and Martin for being today with us and talking about closed loop urban farming, recycling water and reclaiming nutrients. The EdiCitNet project is funded by the European Commission. It's a very large project with more than 30 partners from totally different organizations, and we talk about edible cities, and we want to anchor edible city solutions into our cities to solve the challenges of urban environments that we have today and also in the future. So maybe shortly at the beginning, for those that are not familiar with this, what are edible city solutions? We understand or we cover with this term a wide range of different forms of urban farming, food production, distribution, and consumption. So we look on the whole loop, let's say, also regarding food waste, etc. These solutions use innovative principles of ecological design, closed material and energy flows. This is the main topic for today, and they provide a wide range of environmental benefits. Very important currently with the heat waves in Europe, of course, the heat island mitigation for cities, the nutrient and water cycling, which will be today a topic, but of course we have also functions like enhancing biodiversity by providing habitat services for a lot of species. What is that? Oh, yeah, okay. The mission of the EdiCitNet project is that we do all this with co-creation. So it means that we really work with local communities on the mainstreaming of edible city solutions as a strategic step towards the development of social, inclusive, productive, biodiversity-friendly, resilient, and healthy cities. Our edible city solutions invite citizens to co-create their sustainable development of their society, to proactively change the urban environment to their own benefits. And so we think that this helps also to induce a paradigm shift of lifestyle of everyone. And we do this with these communities of knowledge and practice. We have a local and regional network, and all these, the teams are called in the project city teams. They are in a collective learning process, which leads to a comprehensive and co-developed knowledge base with contribution from theoretical and practical context. So in this sense, in the project, we all are experts. Here you can see also the different cities that are involved in the project on the map. And if we go to the next slide, you have different working streams in the project. One are the living labs, where we are currently testing adapacity solutions and also water and nutrient cycling. And we have the master plans that are that will be developed or are in development for some of our cities. And all this we are doing by co-creation. Yes, and of course, Eddie will surely will post a link in the network. Please join the network. You will get there a lot of interesting information, but you can also share your experience, and we can learn together. And now I hand over the word to Erwin, and we will learn things about water, urban water, and nutrient cycling. Thank you.
I'm going to start with the talk, and Erwin is sharing the slides, so I'll have to tell him to move to the next. And my task is to tell you why we should switch to closed-loop urban farming. And Erwin will afterwards show you very beautiful examples of how we can already do it. I want also to say that we're actually all experts here, but possibly not all in the same field. But that is what makes our discussion interesting, because everybody has at least some expertise. Erwin, next. I don't think I'm telling you something new if with these planetary boundaries. We have been, so far, we have been colonizers. Our strategists, we have been colonizing something we considered boundless, our globe. And all of a sudden now we're realizing that the globe is not endless, and we're bouncing against physical boundaries. And this is a quite new situation, which we have still problems to handle. We even have problems to realize that there are these boundaries, because for individuals, the globe is still very large, and we can't, some of the boundaries, we can't really see them. We just experience them through feedbacks by nature. And if nature is colonizing a confined system, it is normally switching from R strategy to K strategy, from colonizers competing for new space to cooperation, to sharing resources, and to cycling resources, recycling them. And that's why we are talking about closed loop farming in cities. Next. Our human community has devised these sustainable development goals for the running period from 2015 until 2030. That's our, let's say, second or one in a sequence of answers to our realization that the globe has boundaries and that we should become sustainable, and which means just changing our behavior in order to last a little bit longer by not threatening our basis of life. And that's something which is shown in this representation of the sustainable goals. There are 17 development goals, which are not separate. Actually, the very introduction to the Sustainable Development Goals states that they're all interdependent and that they can't be achieved individually because they're linked together. But they're not all equal. And the bottom 4, which are titled the biosphere, which is biodiversity on land and in oceans, water and climate, these are somehow physical and natural pillars of life on Earth and also of our life. The others, society and economy, are man-made or human-made, let's say human-made, and are more negotiable than the bottom 4. We can't negotiate physics. That's impossible. Climate and water cycle and these things just happen according to physical laws. And if we ignore them, they still happen according to physical laws. So we should rather take those laws into account when we deal with these phenomena. Next. So nature, the answer of nature to a confined environment is cycling. And that's something we should learn, and we can learn it from nature because it does it all the time. And that is why we should cycle resources, especially where we live. And the largest numbers of people, next, is in cities. And that's why we should cycle resources in cities. And we think that growing food in cities, making cities edible, is an important element of closing these loops. You have a lot of elements of life included in that. You have the food close to where the people live. But cities are provided with a lot of water, so you always have water available for irrigation of the food. You also have the citizens produce actually or release the nutrients they need, because an adult person doesn't store anything. They just use the substances they eat and then release them again. So you have the nutrients for the plants to grow the food available in cities. There's a lot of other aspects that make us think that edible cities could help us to close loops in a very close to, very near to where the people live. You have seen the triangle representation of this picture. I chose to put the different aspects, economy, social, society, and environment, into circles and increasing circles, because first, the triangle somehow suggests that there may be a competition between the three, which is not the case. There is no competition. Economy has to fit into society and does actually fit. There's no economy outside society. And society, people have to fit into nature because they are nature, and there is nothing outside nature that we can think of. And that is something that these cycles suggest. Otherwise, the elements of the within the triangle, and in these cycles are the same. And if we go to the next slide, we can see that with edibility in cities, we can cover almost all the sustainable development goals. Possibly all. I didn't try to exaggerate, but at least these, there are 6, 9, 12 of the 17 goals are covered just because we make our cities edible. So that's already very good in terms of achieving the sustainable development goals. That should make us consider edibility of cities at a large scale, because then it has the real impact that we're looking for. Next. Now, we're talking about loops, and as much as possible about small, very local loops. And in sanitation, around the year 2000, in sanitation, experts devised this idea, this concept of the household, of the smallest unit to be considered, and to make sanitation household-centered. I would expand this to all aspects of the city, and to look at issues that we want to solve first at the household level, and to solve everything that is possible at the household level. And only when we have reached, or when we have found all the solutions we can have at the household level, then we go to the next, the neighborhood level, for instance, and look at the neighborhood level, what else we can do there, and then to the next larger level. And when we're at the country and the laws that we have to have for the entire country to solve our issues, then we go back to the household and do this cycle again to figure out what can be solved at the smallest possible level, because first, that is what nature is normally doing, and second, it is easier to solve things very often at small levels, and so we should start there. Next. Well, not everything is at a very small level. We all know the water cycle, which has a global, which is actually working at a global scale. But not everything is working at a global scale. If we are looking next at the water path on land, we can see that actually most of the rainfall, look at this circle here. These are, the figures are 1,000 cubic kilometers per year of transported volume of water. And the red and blue is just observation and a model calculation. But roughly there's 110,000 cubic kilometers per year of rainfall of continents, on continents. And actually 2/3 of it come from evapotranspiration from land, and only roughly 1/3 comes from the oceans. So the water cycle that you know, that water is running to the oceans and then evaporating there and coming back as clouds, that is just a small part, the smaller part of the water cycle. And if you look at the figures related to evaporation and transpiration on land, you see that only a small part, a very small part, is evaporating from open water surfaces, and most of the evaporation on land actually is done by plants, by transpiration. And That is something we should take into consideration. Next slide. So we have these small water cycles, or let's say the reduced water cycles with of evapotranspiration on land and rainfall on land. And they're important for us. They're important for rainfall on land. But when we look at our cities, what we did in our cities was drainage. We completely neglected evaporation. When we have rainfall in cities, what we want to do is to drain it off to keep the city dry. That is not what nature does. Next slide. Nature actually stores the rainfall that falls on land and evaporates most of it through plants. And only a small part is running off at the surface. Only a very small part, actually around 0 to 10% normally. And 30% is going into the groundwater, and 70% of the rainfall is evaporating. That is what we should come back to in cities too. We are seeing now overheating of cities. Well, that's because of a lack of cooling, and cooling in nature, energy dissipation is done with water. And so we should keep water in cities and store it for the times when we need cooling. Next slide. But we also have household water, a lot of household water, 150 liters or 100 to 150 liters per person. And only a small part of this is actually loaded or is nutrients, or let's say highly, as we call it, polluted, but it's actually not polluted, it's loaded with nutrients. Most of the water is gray water, and Erwin will explain what we can do with the gray water. But we have those nutrients. We should keep in mind that we have in our wastewater or in our excreta, if you want, nitrogen, phosphorus, potassium, we have carbon, and these are valuable substances. Now we are sending them off the city, out of the city, with potable water. We are flushing them out with potable water. That's something we should stop, and we should try to recover these nutrients on site to grow food. Next. In order to make cities like that, with a lot of water, with storage of water for evapotranspiration through plants. And the plants could be crops. And if we have crops, those need nutrients, and the nutrients are available in the city. And we need to figure out how we can close these loops, possibly with the present technologies, but also possibly with new ones. Anyhow, Erwin is going to show now some of the technologies which allow us already to close these loops. Thank you very much.
So, thank you, Martin, for the general and clear overview. The wastewater how we handled wastewater today is in the spirit of 100 years ago, and it's not really updated. Especially the sewers make a lot of problems. We have problems with rats. The wastewater treatment is very energy intensive, and the sludge, which is one of the results of wastewater treatment, can't be used in the fields, because usually it should go to the fields, because the sludge is high concentrated with nitrogen and phosphorus, but it doesn't go to the fields because the sludge is polluted with heavy metals, with organic matter and so on. And now the way is more open to burn the sludge. This is not a happy solution. And on the other side, what comes out in a liquid form is not suitable for irrigation in the fields, and it's not suitable to use to have a bath near where the water comes out because of hygienic reasons. So what we do need for urban farming, of course, this is water. And how much water we need, for example, to produce 1 kilogram of tomatoes is dependent on the region, and of course it is dependent of the technology, how we irrigate our plants. So, for example, in Spain, I found in literature, we need around 48 liters per kilogram of tomatoes. It's a hot region, and the irrigation technology is not so advanced, developed. On the other side, in the Netherlands, it's more cold, but with an advanced technology, they only need 2 liters per kilogram. Germany is in the middle. But we should look only to the water, we also should look to the energy part. So sunlight will give us a lot of energy. It's around a little bit more than 1000 watt per square meter. LED lamps, which are used in indoor farming, it's approximately about 300 watts per square meter. And so to produce lettuce or tomatoes inside buildings, we have to take into account that the energy balance. The other point, the next thing, what we need for urban farming are nutrients. Usually more and more mineral fertilizers are used, and the production of mineral fertilizers is very energy intensive. For example, to produce 1 kilogram of nitrogen, we need 2 cubic meters of gas. And of course, you know that gas is very rare, especially in these times, and it's more and more expensive. So, and on the other side, nutrients at least comes to the wastewater, and on the wastewater treatment plant also we need a lot of energy to remove the nutrients, and this doesn't make sense. We should bring the nutrients direct to the fields. So it's not only nitrogen, it's also phosphorus, and phosphorus is very rare. The peak phosphorus will be in 2030, and more and more of the phosphorus, which is a mining product, is polluted with heavy metals. It's polluted with uran. And of course, we shouldn't forget that, that there is a war between Morocco and West Sahara, because everyone wants to be the owner of the phosphorus resources. And without phosphorus, there is no life possible on Earth. We can't subsidize phosphorus as we can subsidize energy with renewable energies. And the third important point is potassium. It's also a mining product. It also needs energy, and it's an environmental problem. Here in the picture on the bottom, you see the big mountains. This is salt, and when it rains, all the salt goes into the environment, and this is also a big problem. So at least Martin always said it, all these nutrients sooner or later comes to the ocean, and from the ocean there is no ticket back to the country. So much of what we needed for urban food production contained in wastewater. Wastewater should be used for irrigation only after a provided treatment, and wastewater is more or less an unlimited source for new water, for energy, and for nutrients. So nearly 70% of the wastewater, of the household wastewater, is grey water. This grey water is low in concentrations of nutrients. The concentration or the biggest load of nutrients are in the black water. And so we should separate black water and grey water inside the building, because dilution with rainwater, black water and grey water is no solution. You can't recycle things if you when you put everything together, then it's very difficult to recycle things. And also the energy point, if we use the warm energy which is in the grey water, which comes mainly from shower and bathtub, we can recycle a lot of energy. The amount which can be recycled by biogas is much lower. It is good to produce biogas, but we have to see if we have a more decentralized technology, we can earn much more energy and we can much more water and nutrients. So don't mix black water with grey water. Never put rainwater into the wastewater sewage. And as I said, wastewater is a resource for new water, nutrients, and energy. So best would be if we don't use water for toilets, and more dry toilets are on the market, but actually I don't know dry toilets which are working comfortable in multi-story buildings. So, but I think it's a thing of development. So what we have done, we are mainly producing high quality surface water for purposes where drinking water quality is not necessary. A project we realized 22 years ago was with rainwater harvesting, and it seems to be very expensive to connect all houses separately on a rainwater harvesting plant. And so we decided to take out the more polluted rainwater from the rainwater sewer. So the first flush of the rainwater goes into a sediment, into a rainwater reservoir, and from there we treated it only with a biological treatment without adding chemicals. After UV disinfection, it is used for irrigation, for toilet flushing, and the quality was as good to reuse as for laundry. So this was one of our nicest projects with rainwater. But the main topic actually is on water recycling. So with the black water, which comes from toilet flushing, here you can see how it looks like after it had been sieved. We produced liquid fertilizer, so-called gold water, where which we used as a fertilizer in the greenhouse beside our water house. This is the grey water, including the grey water which comes from kitchen. So it comes from bathroom, from shower, from bathtub, from hand washing basin, from washing machine, and also from the kitchen. So the result is a very clear and hygienic, safe service water. If you have drinking water beside our service water, it is difficult to see the difference between both of them. So it is important. So to produce a good surface water quality is not so difficult. And the more difficult is to reach this goal with low impact of energy and maintenance. And we developed a multi-stage biological cleaning without chemicals and using only UV light. So from So for the surface water we use for food production and also for fish production. And as our colleagues from Terra Urbana showed, that even the black water or the gold water, which was the fertilizer from plants, produced a very good food quality. So I think we are short in time. I will go over. Also using, as I said, the energy, the warm energy from the gray water by a simple heat exchanger can reduce our energy consumption very good. So our latest project, which we realized in the beginning of this year, is a greywater recycling plant for a student hotel for about 450 beds. We are cleaning 15 cubic meters of grey water a day. And this is a little bit more than we need for toilet flushing.
So which color do you?
Sorry? Which we
This one,
produce
yeah.
for toilet flushing. And it also could be used for irrigation. But in the beginning, we are not successful to convince the investor to have a green roof and the green roof used for food production, maybe in the next plant. So here on the slide, you have the link to a small video film which will explain how it works. So another project is with the housing association. We have greywater recycling, and here we have a green roof with a 20 centimeters layer that is after it is not yet finished. And here the green roof is made for beekeeping site. And also on this area, it is planned to install a greenhouse. So the actual project is going directly to the EdiCitNet project. Here, this is for the Guten in Berlin. We made some research in our water house in Berlin, how to deal with grey water, how we can dimension a cheap grey water recycling plant. Here you can see these are normal columns as used for the sewer. We make the scheme, and now we are realize the system. It's
it's black water recycling, isn't it, Erwin?
It is no, it's not black water recycling. It is this is grey water recycling. It is on the Gutshof, where Prinzessengarten are dealing with our living lab. And here they have composting toilets, and we are dealing with the grey water. This is the receiving tank. In front of them, we have a sedimentation, and because the main water comes from kitchen, and to separate the fat, this is a chamber here. So we have here the foam cubes where the bacteria are sitting, and they are cleaning the water. So the columns are a little bit or much bigger than we really need for this plant, but it is planned also to give black water or the mixed water from the neighborhood to this one, to this plant, to make some tests in the future. So I'll come to our latest project, which is in the planning process. It's in the It lays all the papers are at the ministry. Here we have not a separation between grey water and black water. It is a youth educational center, a little bit outside of Berlin, with about 120 beds. And here we will treat the wastewater very carefully, that it can be used for the 1 hectare big meadow orchard. So as we saw when I was first time on this place, I saw that the apple trees are suffering from water so much, and now we want to reuse the recycled water. So sometimes people say we need guidelines, we need more regulations, but I would say we have a lot of guidelines, and for all of those who want to realize these things, we can do it. We shouldn't wait. So this is my last slide, and I cited Guten: knowing is not enough, we must apply. And willing is not enough, we must do. So thank you for your attention.